Subtopic number 3, variation of resistance with temperature. In this subtopic, you have to be able to explain the effect of temperature on electrical resistance in metals and use this equation. So the alpha here is at temperature of 20 degrees Celsius. The value is at 20 degrees Celsius. So what is the effect of temperature on electrical resistance in metals? So we know that the resistance of a metal will always increase when the temperature of the material increases. Okay, so as the temperature increases, the ions of the metal will vibrate with greater amplitude. This will cause the number of collisions between the free moving electrons ni, dia akan collide with each other, and the metal atoms so the metal and then the electrons ini dia akan langgar-langgar this metal. So the rate of collision ni, the number of collisions ni akan increase when the temperature increase. So what is happening is when they are moving a lot faster, it prevents the drift of the free electrons through the metal. So what's happening is the resistance will increase. Okay, so that is the effect of temperature on resistance. In short, the resistance will increase when the temperature increases. Okay, resistance and temperature. So the resistivity of a material varies with temperature. Over a limited temperature range, the resistivity of a conductor varies approximately linear with temperature. Okay, so as we can see here at this point here, the resistivity increases with increasing temperature, and the equation to calculate the resistivity is this one. Okay, because resistance is proportional to resistivity, we can write the variation of resistance as the one shown here. So R is the final resistance, R naught is the initial resistance. Okay, temperature coefficient of resistivity alpha is known as the fractional increase in resistivity per Kelvin temperature rise from the resistivity value at some reference temperature. So the reference temperature depends on the questions. Dia bagi tahu berapa temperature dia. Oh, but for you it is 20 degrees Celsius lah. So delta rho is rho over rho naught, delta T is T over T naught lah. So basically this is final, this is initial. SI unit untuk alpha is per degree Celsius. Okay. Oh, okay. So this is only one example. Example 5. The resistance of a tungsten filament of a bulb is 190 ohm when the bulb is light up and 15 ohm when it is switched off. Calculate the temperature of the filament when it is switched on. The room temperature is 30 degrees Celsius and the temperature coefficient of resistance tungsten is given here. Okay, so what is the final? Okay, they minta temperature when it is switched on. So when it is switched on, it's basically the final one lah. So the resistance final is 190 ohm. Initial is 15 ohm. And then the room temperature, so that is when it is switched off, it is 30 degrees Celsius. Alpha is 4.5 times 10 to the power of negative 3 per coulomb. Per degree Celsius. Okay, so sekarang ni kita just straightforward guna the equation. 1 plus alpha T minus T naught. Okay, so this is 190, this is 15, 4.5. Silap. Okay, so this is what we are looking for, minus 30. Okay, so macam mana kita mau solve ni? Saya akan pindahkan dulu yang 15 tu pergi sebelah. So 190 over 15. So kita dapat this equation di sebelah. So 4.5 milli darab dengan 30 dapat 0.135. So 1 minus, this is 38 over 3. So 1 minus 0.135 is 0.865. So yeah, just rearrange this one. minus 0.865 divide by 4.5. So the temperature is 2622.6 degrees Celsius when it is turned on. Okay? So yang ini memang, it's not really a long solution, but basically banyak maths lah. Just don't do any careless mistakes at this point here. Starting from here lah, basically. Okay, so that is on our third subtopic.